So notice how we have left join, open there, closing here. In between that, we do S19 pipe. I'm just going to give return a couple of times so it's easier to see. And we're going to transform or force this S19 to be seen as a data frame. So there's a function called s.data.frame. And if you don't have to do what I'm going to do next, but if I just run this piece here, we do get a data frame. So we don't see the two panes anymore. It's just one pane for the data frame, but we still have this geometry column. And I want to basically remove that. So if you recall, to remove a column, we use, well, let's add a pipe, hit return. We use the dplyr : select, and then we say what we don't want to keep, in this case, geometry. So we say minus geometry. Okay, so if you just run this piece of code here, so this piece of code, which is transforming S19 to data frame, should yield this. And then now we're merging, we're doing a left join of this with S17. So if you just run all this, it should work. And it says, it tells you here that it did find a common column called ID, and it's using that column to make the join. So if we just print stall, now it's gonna have, so ID, IP yield, and SN yield and geometry are coming from S17. And then the only thing that was different between S17 and what we did here was that SN yield 19 column that is coming from the 19. So now we have a column for the spatial normalized yield for 2017, one for 2019, and I want to do this again for the 2020. So we have all three in the same object. So if you want to simply copy this, so if you have your cursor on the line number, you can just right click and drag to copy all that. You can just copy it. And then you come at the end here and you add a pipe, hit return, and paste it. And then the only thing you would change is that we're doing what you just pasted. We're going to do S20 instead of S19. So we're starting with S17. We're bringing in the SN yield column from the 2019 and then from the 2020. So if you run this now, it does two joins, right? The first one for 19, second for 2020. And then if we print it, let me leave the code there so you can see. We see that we have the spatial normalized yield for 2017. We also have for 2019 and for 2020. So that's what we needed to have in order to then create the conditions. If SN yield in 17, 19, and 20 are all the same, do this. If they're different, do that, right? Okay. So if you were able to do this successfully, you can add a pipe here, hit return, and we're going to create now a new column here that's going to be one of three values. So it's going to be either stable high, which means a pixel was high throughout all years, stable low, which was a pixel low all years, or unstable, meaning that it flipped from high to low at least once in 3 years. To do that, we're going to use, again, the column mutate to create a new column. The name I want to give the column that's going to have these three categories is STN yield, meaning spatially temporal normalized yield. I know it's kind of confusing. Sorry about that. And then we can just add a equal. And now we have three conditions, right? So we're going to use, again, the case when function. If you have your cursor in between the opening and closing parentheses, you hit tab, or sorry, you hit return to make some space so we can see it. And now the condition is going to be a little bit more complicated, not too much, but a little bit. So here's what I want to tell it, and I'm going to tell you in words first, and then we're going to see how that translates into code. And I repeated this a few times already. I want to say, if SN yield in 17, 19, and 20 was always low, you call it stable low. If it was always high, you call it stable high. If it changed, you call unstable. Okay, so these are the conditions that we want to tell the program. And I just wanted to give you that heads up first, because maybe your engines are clicking and you're already thinking of ways that we could do that. I'm not going to ask you to do that yourself. I want to show you, but maybe in a homework or something, I'll make you think more about that, or I ask you to think more about that. Okay, so the first thing we're going to do is copy that. I mean, you don't have to copy, but to say the SN yield 17, which is the name of that column for 2017. And the condition is if this is the same as in 2019, so if 17 equals 19, it doesn't, if you would think you could just say equals 20, right? So if 17 equals 19 equals 20, then something, but it doesn't quite work like that. Like the syntax doesn't work like this. You have to actually add a symbol, a Boolean symbol called and, which is that. So for me, it's above the number 7. So you have to look for that in your keyboard, is that E, funny E symbol. And just to make it easier to see, after that E, after that and, I want to hit return, just so we see better. So if 17 equals 19, and, so it's giving the condition and 17 equals 20, right? So both of those conditions have to be met for it to do what I'm going to tell it next, right? So 17 equals 19 and 17 equals 20 at the same time. Then, and we say then using the tilde symbol. Oh, actually, there is another condition here that I forgot. So right now we're just saying to be equal. So it could be equal low or equal high. How do we differentiate that? We also have to give another condition right here. So we added and, hit tab again, SN yield 17 equals to low. So I know this can be a little bit complicated, but here's what we're saying, right? If 17 equals 19 and 17 also equals 20, so meaning all three have the same value and that value is low, then we want this new column STN yield to have a value, so tilde, open close quotation marks, of SL, standing for stable low. So it is low, it was low all the time for all 3 years. Okay, so this altogether was our first condition, and you had 3 subconditions for that to be met. Now, let's add a comma and hit return. I just want to ask you to copy these lines of code here. So starting with SNU 17, you can just copy that and paste it. I just want to give another return just so it's easier to see. How would you change this condition to say that if it was high all the years, call stable? I'm just going to change here already to SH, standing for stable high. What would you change here to make this work the way that we would hope it to work? What else would you change?
That the SN yield 17 is high.
Right here?
Mm-hmm.
Yes, absolutely. That's exactly what I would do too. So you're basically saying if 17, 19, 20 are the same, and one of them, in this case 17, is high, then that pixel would be stable high. Awesome. So we established stable low, we established stable high, and now unstable, right? So I'm just going to give return here and get to the last condition that we're going to give it. The way that we can specify unstable, there are a few different ways. There is a very complicated way, because if you think of it, there are 3 years, right? 3 years and 2 values that each one of those years can take, high or low. So you can create all the possible combinations of high and low between the 3 years and specify there, which is the more complicated way of doing this. You could if you wanted, but we're not going to do that. We're going to do a simpler way, which is basically in the lingo of case when, you just say So we gave the first condition SL, we gave the second condition SH. And then now the third condition I want to give it is else. Else meaning if a pixel doesn't fall within the first category and it doesn't fall within the second category, then you classify it as something else. To do this else statement in case when lingual, we just say true to the uns for unstable. So this true here is basically just saying else, if else. If the first one doesn't match, if the second one doesn't match, then you classify that pixel as unstable. That's what's going on here. Okay, so if you just go ahead and run this. So I just ran, I'm going to print it now. And I'm going to come back to my data frame here. Now we see that we have this third or this last column here called STN yield, which is what we called up there. And now this column is going to have values ranging from, it's going to have values SL, SH, and UNS, right? So we can see them across there.
Dr. Bastos, can you please explain the third condition again, please?
Yeah, so this condition here, so when you use this, this notation of T, which in R means true, perhaps it's not very intuitive the way that they made this, but it's basically saying if an observation does not fall within the first condition, right, which is same classification in all years, and that classification is low. If this is not the case, then it comes to the second condition, which is all observations are the same for that pixel, and it was classified high for all 3 years, then stable high. So if an observation, let's say that in 2017 it was high, but then in 2019 it was low, in 2020 was low. It would not match the first condition, it would not match the second condition. So it would fall within this else, which we specify with the T, the true. However, if you think about it, unstable could be many forms, right? It could be high, high, low, 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 high, high, low, high, right? There are so many combinations there that unstable could fall into that it would be perhaps a little bit too difficult to really, not difficult, but just take more time and thought to think about all the possible combinations that would be unstable and to write them out here. So in our case, I'm just saying that whatever is not stable low or stable high is going to be classified as unstable.
So just to break down the whole case event thing, is it okay to say that that when you write true, then this, it just means that that if all my conditions above are not mentioned, everything else is when true, do this? That's a perfect summary. That's exactly it. Thank you.
Yeah. Was this confusing to someone else? Like, did you guys follow on Zoom? Because I know this can be very confusing, so I just want to make sure that you guys understand what we're doing. Okay, I'm going to take that as a not confusing or maybe too confusing. And I'm just going to keep going. So if you run this, again, you're going to have the data set with the columns for each one of the 3 years, and also this new column that we created called STN yield. Okay, so I noticed from the beginning of the exercise, I noticed something wrong, and I wanted to wait until we got to it to fix with you guys. So so this map here is basically showing the map of the field with the fill using that classification that we created, so the spatial-temporal. If you run this, you're probably seeing this, which is not right. And I kind of noticed that in the beginning, because I think what happened is let me just stop for a moment and acknowledge something else first. So this is not the map that I had produced when I was when I was developing the script. And it should not look like this. And maybe you don't know yet how it should look like, because right now it's nothing really, basically it looks like everything is unstable, right? Which is not the case. Now, let me tell you, and we can just stop right here for a moment, because one thing I want to tell you is it's easy and normal to make mistakes in programming. And I just want to show you here, I made a mistake and how I'm going to fix it. So I think this is also an important exercise, is just, seeing how to troubleshoot things. And in this case here, maybe I kind of already knew that this was going to happen when I started the script, and I was just waiting to get to here. So maybe if this happened to you, it was not going to be as clear cut to find the issue. But here's what's happening. So I'm going to go back up to the setup part where I have the data sets being printed. So I don't know if you noticed throughout, but the EO17 data that we imported had double the number of cells or observations than the 19 and the 2020. So they should all match. They should have matched. The number of observations should have matched for all three layers. But a 2017 had the double. And when I was going through it, and I think what happened in my case was that at some point during the previous exercise, when we created this layer here, I changed the resolution from 10 to 5 of the grid to show something that someone asked. And I didn't rerun, and I didn't change back to 10 and rerun and export it with the proper resolution. And you can kind of see that, like when we look at the three maps together, you can kind of see that too. You can kind of see that the 2017 is finer scale than the 2019 and 2020, just looking at this map. And that's basically why in my case, this map looks like this, because we have the 2017 with a 5 meters resolution and the 19 and 20 with a 10-meter resolution. And so things got very mixed up and confused. And I want to ask you guys, are you seeing what I'm seeing, or are you seeing something that you can clearly see three categories? So Spanish seeing what I'm seeing? Victoria, are you? Oh, of the map?
Before that, right before that.
Like on this code here?
Yes.
Mine matches yours.
Emily, did you say that yours matches mine?
Yes, sir.
Okay.
I can see three categories, but the thing is, in the beginning, I had the 2019 with 8,000 observations. So I thought it was just a wrong, and then I replaced it with the ones you had on GitHub. So, but now it runs, I have the normal map. It has a SHSL and unstable ones.
Yeah, so this is, again, so I got to this point, I know that this is not the map should look like, and I kind of already knew what caused it. But so how do we fix this? And maybe, maybe we can focus on finishing this lab, meaning going through this fix as well, and finishing this lab today, and then leave the terrain one for the next class. But I really want to fix this, and I want to show you guys how I would fix this, right? So if we think about it, at least in my case, the problematic one is the 2017, which has, so the correct number of polygons we should have was 4,032. This is the correct number. So in my case, 2019 and 2020 are on the correct scale. But 2017 is not. So for me, what I would have to do is basically, I'm going to come on my files, go to the root directory, go to code, and I'm going to look for the script that I had where I did the interpolation for the 2017, which in my case was interpolation partial. So that's how I named the file that exported that 2017 one. So in my case, I'm basically going to have to rerun this script and make sure that I have the correct number there when I export this map. So I'm just going to go through that myself. If you want to do that yourself, you can. What I'm going to do is I'm going to create this 2017 correct layer, and I'm going to put that on GitHub. So if you want to do that too, if you just want to copy from GitHub after I'm done, you can do that too. But I just wanted to show you. So I'm basically going to recreate that layer, the clean interpolated yield data for 2017, which again, in my case, that was the one with the issue. So I'm just going to do that here. I'm going to skip the chunks that are just summary or plots. I'm just going to focus on the ones that bring in data and process data. So I can skip the map, going to create the grid. And hopefully something that you guys also, oh, okay. Oh, this is just a block. Something that probably you also notice. Okay, so here we go. So 10 and 10. Yeah, so here's correct. Maybe I corrected the number, but didn't rerun the code when we were going through this. But hopefully something that you realize is that once you have these codes developed, it's pretty fast to just change the data, quickly adapt, and just go through the analysis, which takes us hours in class, but after it's ready, it's pretty straightforward. So I'm just going to do that here. This is just plot. And I want to print this to make sure that I have the correct. Okay, so here we go. How do I check that I actually fixed the issue? So I just printed here the object that has the interpolated map for 2017. And now it says 4,032 observations. So great, this is what it should have been. I don't think write SF would let me overwrite the file. And maybe that was also part of the issue. Maybe I did run everything, but when I exported, it didn't let me. So I'm just going to come here and delete the one I have. And now write this back there. So I see it there. And as I checked that it has the right number of observations, 4,032. That's what we wanted to have. Okay, so I'm going to close this script now. And I just wanted to come back to where we were and re-enter or rerun this just to make sure that now it has the proper number. Yeah, so now it has 4,032, my 2017. So now it matches, okay, in my case. That's how we fixed it. Let me do this. I want to update on GitHub this one. So let me do that right now. I'll have this data here. It is 2017, that one right there. I'm going to go to my GitHub one, paste here, replace. So I just replaced on locally on my GitHub, and now I'm going to send it to GitHub so you guys can have it as well. So let me, and what I'm doing next is nothing you have to worry about. It's just a little bit of terminal using Git and GitHub. So if you don't understand what's going on, no worries. Okay, now it should be up on GitHub. Let me check. So if I go on GitHub and I go on my updated, okay, 16 seconds ago. So if you guys go, if you go now to GitHub and copy that 2017 clean IP, download that to your computer, copy this specific file into your own data folder. This should have the correct dimensions. That was a mistake before. So I just want to give it a brief moment here for you guys to catch up. And again, while we all do that, I just want to tell again that you probably already noticed programming, even though like I tried to develop my scripts in advance and make sure that no bugs are in there so you guys don't get confused. Sometimes that happens, but I can assure you that while I'm developing these scripts, I run into multiple issues, and your best friend is really Google, just like Sometimes just Googling the error that R is giving you can be helpful. Sometimes it's not that much helpful, but it's really like a skill, like programming in any language. This is a very important skill, how to troubleshoot errors, because for sure everybody gets errors as they're developing things. So as you guys are like downloading from GitHub, copying that file into your data folder, once you're done with that, please let me know so I know that we can all move forward together. How you guys on Zoom doing? Anyone's able to complete that? So Tyson's nodding yes. Sunab as well. Emily's nodding yes. Give it a moment here for Sarah and Janice. Sarah, are you good? Janice, are you still working on it? Okay, so I'll give you a moment to finish. I think Victoria is also finishing up.
I'm good. I'm ready.
You're good. Okay. George, were you following along?
I abandoned the ship a little while ago because I had something to do here at the office, and I haven't caught up. So don't worry about me.
Awesome. Okay.
I was following until about 10 minutes ago. No.
So Victoria, let me know when you're done and we'll continue.
Dr. Bastos, since the others are still doing it, I still don't understand why having more polygons in one shapefile messed up the whole map.
Yeah, it's basically, so let me come back to the code here. So we can kind of check on that when we are doing the joins. So if I'm just gonna print here the S17 below so we can see, so he has like double the amount of observations, right? So my guess, let me do a quick trick here, just to explore a little. So
Is it okay to say that actually, since the resolution was different, there was no pixel, no polygon that was same as the other ones?
So what was going on is, because it was using the column ID, right? And what happened is, if you think about it, ID for S19 and 20 were going only all the way through 4032.
Yeah.
So any ID greater than that, I actually don't know how it was handling behind the scenes, but it was not able, it should not have been able to merge any ID greater than that. I guess what we can do here, let me just do a quick, you don't have to do this, I'm just doing some on the go trick here. But I want to just transform, because right now ID is character. I want to transform that to numeric first. And I'm just printing that. I'm not really, yeah. So now it's double. I'm not really saving these changes, and I don't want you to save them either. But I just want to do that so I can sort ID numeric and see how it was handling. So if we, I mean, all the way through here is probably matching the same. So 1,000 and 1,000, but I want to see what happened after like 4,000. So to do that, I want to use the function slice, which takes a slice of the data set based on rows, on row position. So I want to do here from 5,000 to 5,500. So, I mean, we see that we have ID there. Oh, there we go.
None for them, yeah.
So we populated the cells with an ace. And then what happens is if you're doing on the case when you're doing the condition and it has an ace, it was just classifying as unstable.
Yeah.
So everything on that finer scale of the 2017 that was not matching with the ID of 19 and 20 was coming up as unstable. And that's why we see the map overly populated with unstable.
Also, we had the geometry from the 2017. If we did from 19 or 20, did that maybe have showed some data? I think so. Because
Yeah.
that would have the pixels from 19 and 20. That was the correct data.
Right, right. So this troubleshooting here to understand what happened with the data set is probably what I would have done if I had not already known the issue, which I did because I knew what.
Yeah.
You know, I knew how many cells we should have had. So when I saw the 8,000, I was like, okay, red flag.
Yeah.
But these are the steps I would have taken
Mhm.
if I had not known that. And then I would have seen this, and this would trigger my thought to think that maybe the dimensions were different.
And just one small thing in this troubleshooting thing you did, instead of doing the ID as numeric, you can we just put slice 5,000 in double commas? That would be okay too, right? Do you think it will process it?
I don't think you would use slice then. You would have to probably use filter because
Okay.
slice works on, well,
Numbers.
I mean, you could have still used this because if you see, I'm not specifying a column on slice because it doesn't take a column name. It is by row position.
Mhm.
So I mean, here, even if I didn't have these, you would still slice just as well.
Yeah.
And I would still see ID there, right?
Mhm.
I guess my trick of transforming ID to numeric was just so I could arrange in increasing order.
Oh, okay. Okay.
Yeah.
Okay, thank you.
Yeah. Victoria, are you?
It's having trouble, it won't plug.
Okay, give me just a moment, guys. I'm just gonna check, help Victoria and I'll be right back. So this is your stuff, right? Oh, I think that what's happening is this script. Maybe where this script here is, maybe it's not in the folder. Yeah, so that's why. So the script is not in that folder, so it doesn't see, you know, that path. Do you know, I'm just gonna save here, but do you know where? So the one that this is the one that you were working on in the beginning. Let me just do. So were you able to import the other ones, the other files?
Yeah.
Okay. So maybe let's just question this. Even this shouldn't work. Yeah, now it doesn't work. It's almost.
Must have messed up when I downloaded the
Is it okay if I help you after class if we have time? Okay, because then I can wrap this up and then we can.
Yeah, sure.
we can call it. Okay, so let's continue and finish up here so you guys see how we will then fix this. What happens is we really have to rerun all this script to this point again for that difference to take effect. What I like doing is if I'm rerunning things in the same script, I like to just clear out my environment. So the environment has all the objects that you created. And the problem is that sometimes we create objects in one script and then we bring another script and create new, perhaps other objects with the same names sometimes. And that can cause issues too. So every time I'm switching from one script to the other within the same project, I like to clear up my environment, and you can do that a couple of different ways. One easy way is just to click on that brush icon right there. So I'm going to do that. I clear my environment and I have to basically rerun at least, I mean, you don't have to load the packages again because we didn't close R, but you will have to rerun everything else that you're importing or creating an object. So before I keep doing that though, I want to show you a trick that I've been thinking about the right time to show you this because I didn't want to to make it too easy for you sometimes. But what you can do is, let's say if we know exactly where our issue was happening, which was right here, and let's say I wanted to run all the codes, all the chunks above it, above this chunk, I can just click on this button here. I'm going to do that myself and let it go. So you can see the progress bar going through here. It's creating all the objects and it's coming through and just finished right there. It is very quick to do that. I only do that if I am certain that I don't have issues above, because if you have errors above, you would have stopped at wherever chunk that error was, and you would not have kept going. So if you had errors, it would show in your console here, like a given error, and you have to go back to that chunk and troubleshoot it. In my case, I was able to get through it because I didn't leave any errors lingering above, meaning I could get through automatically to this chunk. So we're not going to go through everything again because everything was still the same. The main difference is that I am expecting now that STL to have 4,032 observations, which it does. So my guess is that now the map should work as intended. So I'm going to run on my side. Yeah, okay, cool. So I'm just going to stop for one moment here and just ask, I mean, I know Victoria wasn't, but we're going to work on that later. Was everyone else able to get to this point here? And if you were not, please speak up. Okay, I don't hear anything, so I'm assuming everybody was able to. So let's just stop for a moment and look at this plot here and think about it, okay? So this plot basically took all the low and highs for all 3 different years, and it classified them as stable high in blue, meaning it was high in all 3 years, stable low in pink, which was low in all 3 years, or unstable, meaning that it flipped at least once from high to low in 3 years. This is really interesting, right? I mean, think about it. Think that if this is your field, or maybe a farmer that you're working with, this is really, really key, right? Because we have areas that we know will, I mean, this is given 3 years only, right? If we have more years, even better. But it's telling you that at least in the past 3 years, you had some parts of the field that always yielded higher, meaning that maybe, even though we haven't done zone yet, but this could be a very important aspect of creating zones, because now you know that parts of the field are consistently yielding higher, have higher yield potential of this field. So maybe you could increase a little bit your nitrogen rate, or maybe your seeding rate, or maybe some other input that you're using in those parts of the field. On the low parts of the field, if you know that they're consistently low, maybe you could invest a little bit less money because they're not returning you as much. And again, this is not a profitability map. So this is what I'm telling you right now is just guesswork, right? We're just thinking about how this map could be incorporated into a recommendation. This is not the actual recommendation itself. But you know, some areas are always high, some areas are always low. But then the biggest and perhaps the most interesting discussion is what do you do with unstable areas? You don't know what to expect. Maybe this year they're going to be high, maybe they're going to be low. You really don't know. So these unstable areas are perhaps the key part to really think about is how are you going to incorporate them into a recommendation? My guess is that, like, if this was my field or maybe my farmer, I would go filter specifically those unstable areas and try to understand, were they high, high, low, or were they low, low, high? I mean, were they high most of the time or were they low most of the time? And then what do you do with that information, right? I don't have the answers. I don't think anyone, perhaps George has some insight here on that, but it's just something I wanted to plant on your heads for you to think about it, because yield is the ultimate variable that we want to optimize. And if it is changing over time, then, you know, how do we go about it? Anyone has?
Leo, if you allow me to share my screen for a moment, I do want to make a suggestion here for students to look at something. So what I would like you to take a look at is, you know, whenever you do this kind of thing, what Dr. Bustos has shown you is just, you know, sort of the top-notch way to approach this problem. But once you have that map that shows the stable high, the stable lows, and the intermediate or the uncertain areas, you know, take a look at aerial photographs and try to understand the terrain that's giving you these results. So clearly, if you look at this image here, the areas that are consistently low are the areas that are either highly eroded or the areas along the edge of the field where the sand is deposited from the erosion. So clearly the consistently low areas make a lot of sense. The consistently high areas, you can see in the images, we have spots where the foliage is different. Even though this is defoliated cotton here, you can see that there's more growth. So clearly the things, it's not a random response that you saw there, right? So
Awesome.
the map has great value there. It's a fantastic map.
Awesome. And this is something that in future labs, where we start doing the zoning, I want to bring this one. So all the layers that we're creating, I just want to make this clear. All the layers that we're creating are going to be used afterwards. We're not just creating random layers. They're all going to be useful. We're just processing them and getting them ready for that step. And so when we get to the zoning part of it, we're actually going to bring back all these layers and try to understand if we can find the main drivers of these unstable areas and even the high and low stable areas as well, to see if they correlate with any other variable. So maybe there's a correlation with elevation, maybe with slope, maybe with soil texture, you know. So we're going to be looking into that in future labs. And just to wrap up here, we just have a couple more chunks that I want to go through. So if you know, this is a field you're working with, and I just want to ask you, if you just eyeball it quickly, just eyeballing this plot or this map, what percentage of the area of the field do you think is unstable? Any guesses? Anything? Victoria?
40%.
What did you say?
40?
40?
Yeah.
You guys here have any guesses different than that? More than 40, less than 40? 40? So it seems like we have a few 40s. So that seems pretty consistent. We can actually calculate that. I didn't leave you the code actually, but it's a very simple code. So we can just quickly go through that. So for us to calculate the proportion of each one of the classes, we're going to start with this object here that we're calling stall. We're going to add a pipe, hit return. And so because I want to know the proportion of each one of the groups, I need to do a group by. So I need to group by that column. I'm just going to print here the stall. So we see again below the column that I'm looking for is stn yield, which has all the three classes. So we do a group by based on that, add a pipe, and R has a function called tally, which basically tells you how many observations are within each one of the groups that we specified above. So if you write that, we can see here the number of observations. And we know, I mean, there are some more automated ways of extracting the total number of observations, but I know that it is 4,032. So I just want to add a pipe and enter a mutate, where I'm going to call this new column prop for proportion, say equals, and then I want to do divide, excuse me, n by 4,032, which is the total number of observations of STL. And then I just want to add a open and close parentheses to close the n divided by 4,032 and multiply by 100. So we get like a number, complete number. So you would have proportion equals open parentheses n divided by 4,032 close parentheses times 100 close parentheses. And if you do this, you guys were pretty good eyeballers. So we got about 43% of the area was unstable, right? So I think it's again a really good thing to think about, right? Many people doing management zones or grid sampling, but the ultimate goal is always, or most of the time, is to optimize yield, right? And if yield is varying so much, not only in space within the field and year, but also across years, then how do we really take that into account? Okay, so last thing we're coding here is just exporting this layer, because as I mentioned, we're going to be using this again in the future. So let's export this layer here. Because it is a vector object, we're going to use write_sf. So notice how to bring in a data, we use read. To export, we use write_, and then what comes after the underscore is based on what type of object you have. So geospatial object, we're going to use write_sf, open and close. Oh, we have to first say what's the name of the object that we want to export. So that's st_all. And then add a comma, open, close quotation marks. We're going to ..forward to get outside of the code folder. We go inside the data folder, and I want to call this exactly as the object name. So st_all.geojson. Okay. So if we run that, well, I got a warning because I had already exported it. So it's just telling me that it's giving me an error. But when you run that, you should not get any errors, and you should see, if you go on your project data, you should see the stl.geojson there. Okay, so this is, so today we brought in all the three interpolated clean yield data sets. We classified them as low and high based on the medium of their specific year. And then we joined those categories on a spatial temporal class using stable high, stable low, and unstable. And then we exported this to use in the future. This is what I had for you guys for today. And I think it was a very nice exercise for me to run into issues and to show you how I would have fixed them, because we all run into coding issues anyways all the time. It's part of programming. And that's all I had. Anyone has any questions, any thoughts? On Zoom, anything?